Okay, so today we're going to look at something that is not very easily understood because it can be a bit confusing, but let me try to give you the best explanation I can. So you have seen that in many problems we need to do either the PV or TV diagrams. And you know that on this side we have a gas, here we'll have a mixture, and here we have a liquid. Okay, so generally you will find easily tables for this side right here. Generally will be called superheated tables. This one generally will be called saturated table. Saturated because here you can have the saturated liquid, or here you could have the saturated gas. That's why they call them saturated tables. It's between those 2 points. But you rarely have a table for this region over here. Sometimes you do, but it's rare. Rarely table is available. Okay, so I'm going to show you one example over here, one example for the water. So the water, your textbook is one of the rare cases, if not the only one, that has the saturated, let's see if I can zoom in. You see the saturated water table, and you have basically temperature, pressure. So this is the saturated, will correspond to this table over here. You also have the superheated, but you will have compressed liquid, where basically you have here the temperature, specific volume, and so on. So basically here what's important to notice is this. Okay, so this is the table for compressed liquid. So basically for this area, this is probably the only table you have in your textbook for that region. And let's look at it. If you look at, for example, let's say at 40 degrees, what would be the specific volume? 0.001057. The internal energy 166.92, enthalpy 171.95, temperature was 40. Okay. Now let's see what happened if we go now, and this would be for 5 megapascal, which is a huge pressure. Okay, that would be the saturation. So now let's say we go here to this table here, which is saturated water, and we look at the temperature of 40. Okay, I think that's one we looked before. So what would be the value over here? 40, we're gonna have V fluid is 0.001008 compared to the 0.10057, so it's off a little bit, but not that much. What about the internal energy? We have 166.92. U fluid will be 167.53, so it's not that off. And if you look at the enthalpy, it's 171.95, and H fluid is 167.53. Okay, so what's happening, what I'm trying to say over here is that if for a certain substance you don't have the table over here, what's important is the temperature, because the property does not change much in function of the pressure. So let me repeat that. If you don't have the table for over here, you go to the tables, the saturated tables between this point and this point, and you look at what would be the property at that temperature, and it should give you the value for over here. So again, let's look at this table again. You look at it here, the pressure is completely different, but I look at 20 degrees. You look at the pressure here is 83.61. This one will be the pressure twice, 83.31, 15, 83.01. So you see that the property is kind of independent from the pressure. However, it's very dependent on the temperature. So instead of having tables created just for the compressed water, as you can see over here, the value doesn't change much with the pressure. What they do in your textbook to save some space, but then it becomes a little bit confusing, is that if you don't have the table for the substance, you need to go to the saturated table and look at the values on the properties, because you know the property will change a lot in function of the temperature, but will be almost constant in function of the pressure. And what is the physical explanation is because if you have a substance that is incompressible, which basically, without getting in too many details, means that the density is almost constant. All right. Basically, what it's saying is that over V, the specific volume will not change if you compress it a lot, but also what we just show is that the internal energy U and the enthalpy H will not change much either. So I know this can be a little bit confusing, but really what you need to remember over here is that there is not many tables for liquid state, and that's because property in liquid state for incompressible substances depend mostly on temperature and not pressure. Let me zoom out so you can read. Sorry for that. Okay, so that would be the end of the video.